Hey Opties! Today we're talking about distance. As you can see, we have a really cool picture of two stick people and an arrow separating them. And this reminds me of social distancing. So keep your social distancing or your physical distancing and be safe. But we're talking about distance. We're going to talk about the distance formula and the Pythagorean theorem. And the distance formula is really just the Pythagorean theorem on the xy plane. Let's look at some examples. So example A is, how would you find the distance of the two segments below, vertical and horizontal? So we're just thinking about vertical and horizontal distance here. So looking at the first one, your y values are the same, and that's because it's horizontal. So the height doesn't change across the entire segment. So all you really need to do is count the distance between your x values. So if you're -2, that's 2 chunks right here. And if you're +10, that's 10 chunks here. So the total distance would be 12. And you could also count from -2 to 0, that's 2. And then you're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that gets you to 12. So two different ways to think about it. I like to look at my distance from the axes to find my distances a lot of times, because it's just easy to think about and to avoid any mistakes made by the negatives. So I just think about the distance from the y-axis, like basically absolute value, right? Just distance from a certain point. So I'm eliminating this -2 and just considering distance. So let's look at the distance of this vertical segment. Notice your x values are the same, and that's because it's vertical. So let's count. -9 is a distance of 9, and +3 is a distance of 3. So 9 plus 3, that's also 12. So the distances of both are 12, and that's just coincidence that they're the same. On example B, we have a diagonal line. So now let's find the distance of this diagonal line by looking at it like a triangle. And technically this is a line segment, right? It has 2 endpoints. It stops on each end, so it's a line segment. So we're thinking about this as a triangle with our dashed lines. So let's go ahead and find the distance between our y values and the distance between our x values. So if I'm going up 9, that's a 9, and I'm going down 3, so 9, 10, 11, 12, that's 12. And this is -4 and a +7, 7, 8, 9, 10, 11. So that's 11 is that distance. So we want to figure out what's the distance of this diagonal line segment. So think back to probably 8th grade and maybe even Algebra 1. When we want to find the hypotenuse, it's a big word there, of a right triangle, we know this is right because it's a vertical line meeting a horizontal line, we will use what's called the Pythagorean theorem. So let's write that. Pythagorean theorem. Okay, so let's do that. Let's say this is A and this is B. And it doesn't matter, this could be A and this could be B. We just know A and B are both the legs of the triangle, aka not the segment across from the right angle. And this is going to be C, what we're trying to find. So the Pythagorean theorem is A squared plus B squared is C squared. So let's do 12 squared plus 11 squared, and that equals C squared. 12 squared is 144. 11 squared is 121. And we've got C squared. So let's add these two. 144 plus 121, 4, 5, 6, so it's 165. And that's C squared. So if we want to find what C is, we're going to take the square root of both sides. Now remember, when you take the square root, it's going to be plus or minus. So it's going to be plus or minus the square root of 165. And that's C. The reason it's plus or minus is because if you are squaring a positive number, it'll stay positive. But also, if you're squaring a negative number, it will still end up positive. Think about this. If x squared is 25, and you take the square root of both sides, you get 5, right? But you can also get negative 5. Here's why. 5 squared equals 25. So we can see that x could be 5. But also, negative 5 squared is 25. Because again, a negative times a negative is a positive. So you always take the plus or minus. However, we're talking about distance. So distance cannot ever be negative. So always when you're doing the Pythagorean Theorem or the distance formula, which you're going to learn in just a moment, always take the positive. So C is going to be the positive square root of 165. So C is the positive square root of 165. And if you want to type that on your calculator, you'll get 12.845. And that's just going to be in units. It's always a great idea to have at least 3 decimal places whenever you are giving an answer that is a long decimal, because it shows some more precision. Because 12.8 is very different than 12.1, for instance. So if you're not doing very many decimal places, then it's not as precise. So always try and use 3 decimal places. So let's take a look at our formulas. We're going to look at the Pythagorean Theorem formula and the distance formula. Draw a right triangle where the diagonal length you want to find is the hypotenuse. This is how you're starting to use the Pythagorean Theorem, just like we saw in our second example, example B. And you can count the height between the y values and the width between the x values to get the leg lengths, A and B, like we just did, of the right triangle. And then use the Pythagorean Theorem. So we can see here, here's a triangle where we have the diagonal is our line segment we want to find the length of. And this is A or B and this is A or B. Again, it doesn't matter which one's A and which one's B. And here's our x1, y1, x2, y2. That's just telling us we have 2 different endpoints. And here's the Pythagorean Theorem. A squared plus b squared equals c squared. Let's look at the distance formula. If you use the Pythagorean Theorem and write A and B as the difference of the x values and y values and solve for c, you get the distance formula. So what I mean here is the distance formula is really just the Pythagorean Theorem. Let's take a look at example B, and I'll show you what I mean by writing your A and B as the difference between the y's and difference between the x's. We got this 12 by counting the 9 and the negative 3 and knowing that negative 3 is positive because it's a distance. So more like reasoning through it and using the graph as our tool. But you don't have to do it that way. Another way is just subtracting those values. So you could do 9 minus negative 3, which is 12, because 9 plus 3 is the same thing as 9 minus negative 3. Or you could have gone the other way, negative 3 minus 9. Now, we know this is negative 12, but it's going to be distance. So it's going to end up positive. Now let's see how it ends up positive in our distance formula. Think about, you're going to square this 12 anyway, because it's either A or B and it's squared in the Pythagorean Theorem. So that's why you're squaring this y2 minus y1 in your distance formula. So when you square something, we've already discussed that even if you're squaring a negative number, it ends up positive. So you won't need to worry about your subtraction ending up negative because you're going to square it anyway and it's going to end up positive in the end. Same thing happens for your x values. -4 minus 7 is -11. But when you square it, it'll become positive 121. You could have also done 7 minus -4 and gotten the positive 11 to start with. But again, either way, they'll end up positive. So the order doesn't matter on which one you call x1, y1 and x2, y2. Now, this x2 minus x1 is like an a. Isn't that what we did to figure out our a value? And this y2 minus y1 is like a b. And of course we're squaring it, because isn't that what we did to get our b value? We subtracted those. Now this square root, didn't we end up square rooting the a squared plus b squared side of our equation when we used Pythagorean theorem? Well, yeah. And if you wanted to get rid of that, you could square both sides of this, and you would get d squared equals a squared plus, from this plus, b squared. And d, isn't that the diagonal segment, just like our c was the diagonal segment? Well, yes. So as you can see, the distance formula is the same thing as the Pythagorean theorem. It's just written as if you're looking at your plane, your coordinate plane, with those endpoints given as xy coordinate pairs. So here's the gist. Whether you're using Pythagorean theorem or distance formula, they both work. And distance formula is essentially the Pythagorean theorem. I call it the Pythagorean theorem on the coordinate plane. But if you are really liking to use formulas because you think it's just more straightforward, then you might just prefer to use the distance formula. I personally only really think about the Pythagorean theorem when I am finding lengths of segments that are diagonal. I don't actually think about it like I'm using the distance formula, even though either way you do it is using the other one because they're essentially the same. All right, that's it for distance notes. See y'all next time.